Is 1.3, and it's called combining transformations. Okay, to start off with this example, we're given a function, y equals f of x, and it's just this funny looking little v function here. Goes up to negative 2, positive 2, 0, 0, and 2, 2. So what are we going to be asked to do with this thing? So what we're asked to actually do in the example is to draw and describe this g of x function that's defined as negative 2f at 1/3 x plus 1 plus 1. Now, if you dive right in and just start describing transformations, you'll get most of the marks here, but there's one little complication to this thing, and we've talked about this one in class. It mentions it in your book as well. But this innermost bracket here should have only an x, not a 1/3 x. So I need to factor out that 1/3. And my function now looks like this. Slight difference. I would have still described the first, most of the transformation is the same, but the horizontal translation looks different. The negative 2 out front, the negative first of all makes me reflect about the x-axis. The 2 is a vertical stretch by a factor of 2 about the x-axis, so my graph is going to get twice as tall. The 1/3 inside multiplied by x is actually a horizontal stretch by a factor of 3 about the y-axis, so my graph needs to get 3 times as wide. The order that I apply those 3 transformations won't matter. I can reflect, vertically stretch, horizontally stretch, or horizontally stretch, reflect, vertically stretch. Any which way, I will end up with the same picture. It's very important, though, that the translations, which I haven't yet described, come after that. So we'll then horizontally translate it left 3 units and up 1 unit. But I'm going to do the shape first. Shape and orientation, reflect and stretch before I start doing translations. So those translations are written now. Horizontal translation left 3 units, vertical translation up 1 unit. Sometimes people like to describe the transformations with mapping notation. So what altogether is going to happen to point x, y? Well, x is going to be horizontally stretched by a factor of 3, so I have 3 times x. It's also going to move left 3 units, so I then need to take 3 away from the x. The reflection about the x-axis is going to change the sign of the y-coordinate. It's also going to be vertically stretched by a factor of 2, so I'll have negative 2 times y. And then I need to go up 1 unit. So if I can perform this transformation on every point, I could do this in one step, or I might want to do these in multiple steps. So to reflect about the x-axis is going to turn this graph upside down, look something roughly like that. To vertically stretch by a factor of 2 is going to multiply my y-coordinates by 2, so they'll now go something roughly like this. We'll worry mostly about the final one being drawn really nicely. Horizontal stretch by a factor of 3 means instead of going 1, 2, it'll go 3, 4, 5, 6 units to the right, and 1, 2, 3, 4, 5, 6 units to the left. So there's my horizontal stretch, puts it somewhere out here. And then I need to do my translations to say, I'm going to go left 3 and up 1. Notice until now the vertex, the point at the origin, hasn't changed. But when I go left 3, 1, 2, 3, and up 1, it does. So that's a very important point. I should definitely label that point to say negative 3, positive 1 is my new vertex. Now I need to somewhat carefully try to move these other points left 3 and up 1. Might actually need to make my axis a bit bigger because I need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1 unit. So up 1 unit puts me right here. We'll let that in a second. Connect the dots with a relatively straight line. And this one, 1, 2, 3, and up 1 is going to be about here. And again, connect the dots with a relatively straight line. I'd like to do these in color for you, but this technology doesn't allow me to do that, at least not this one. Label these points. I've got 1, 2, 3, negative 1, 2, 3, 3, negative 3 for this one. And this one is actually way over here at negative 9, negative 3. If you check the dimensions of this final graph, you should see that it's exactly twice as tall and 3 times as wide as the original, and it's been moved left 3 units and up 1 unit. So there's combining transformations in 5 minutes.